Alright, so what's the deal with computer engineering? Let's break it down. Think of it as the field where brilliant minds design and build computers. And not just the computers on your desk. We're talking about all sorts of computer systems, big and small. It's about making technology work, from the tiniest chip to giant supercomputers. Computer engineering is really where the magic of modern tech begins. It's a super exciting area to be in, trust me. It's all about creating cool new things that can change the world. This field blends two major areas, which is pretty neat. Computer engineering is a cool mix. It takes ideas from electrical engineering. It also pulls a lot from computer science. So you get the best of both worlds, really. Engineers in this field understand the physical parts, the hardware. They also get the instructions, the software that make the hardware do stuff. It's like knowing how to build a car and also how to drive it expertly. This combination is super powerful. It allows for a deep understanding of how tech actually functions. You're not just using tech, you're creating it. The scope of computer engineering is huge. Seriously, it covers everything from designing microprocessors. Those are the tiny brains inside your phone and laptop. It also extends to developing huge, complex systems. Think about the massive servers that run the internet, or the guidance systems in rockets and satellites. Computer engineers work on all of that. They are the architects behind so much of the tech we rely on. It's a field with incredible range and impact. At its heart, computer engineering is about solving problems. It's about looking at a challenge and thinking, how can tech fix this? Engineers use their skills to create innovative solutions. They design new products. They improve existing technology. They make things faster, smaller, more powerful, and more efficient. This means constantly learning and adapting. The tech world changes fast, so you have to keep up. But that's part of the fun, right? Always something new. So, let's talk about hardware. What is it? Hardware refers to all the physical parts of a computer system. These are the components you can actually see and touch. Think about the case of your PC, the screen of your laptop, or the keyboard you type on, and the mouse you click with. These are all examples of computer hardware. It's the tangible stuff, the real deal physical components. Without hardware, software would have nowhere to run. It's the foundation of any computer system. Inside your computer there are some key hardware pieces. You've got the central processing unit, or CPU. This is the main brain. Then there's random access memory, RAM, for short-term tasks. The motherboard is like the central nervous system, connecting everything. Graphics cards, or GPUs, handle all the visuals, especially for gaming. Storage drives, like SSDs or HDDs, hold all your files and software. All these parts work together in a finely tuned dance. Each one plays a critical role. Understanding them is key to understanding computers. Now, how do these components actually work? Let's simplify. The CPU executes instructions and performs calculations. It's the thinker. RAM provides fast, temporary storage for data the CPU is actively using. This allows your computer to multitask smoothly. The motherboard provides the pathways for data to travel between components. Graphics cards render images, videos, and animations on your screen. Storage drives keep your operating system, applications, and personal files safe. It's a complex system, but each part has a clear job. Computer engineers make sure these parts play nice together. Computer engineers are the ones who design and improve this hardware. They work on making CPUs faster and more power efficient. They develop new types of memory that can hold more data. They design smaller, more powerful components for mobile devices. This involves a lot of research, development, and testing. The goal is always to push the boundaries of what's possible, to make technology better year after year. It's about constant innovation in the physical realm of computing. Pretty cool stuff, if you ask me. Alright, we've covered hardware. Now let's get into software. Software is basically the set of instructions that tells the hardware what to do. You can't physically touch software, unlike hardware. Think of it as the intelligence, the brains behind the brawn. It's the code, the programs, and the applications that run on your devices. Without software, your powerful smartphone would just be a fancy brick. It's what makes your computer useful and interactive. Software brings the physical components to life. It's the director of the entire technological orchestra. Software comes in many forms. You use it every single day. Operating systems are a big one. Think Windows, macOS, Linux, Android, or iOS. These manage all your computer's resources and provide a user interface. Then you have application software, or apps. These are programs designed for specific tasks, like your web browser, your favorite game, or a photo editing tool. Even the firmware that controls your smart fridge is software. It's everywhere, making our digital lives possible. Each piece of software has a specific purpose. There are generally two main types of software: system software and application software. System software manages the computer hardware itself. It's foundational. Operating systems are the most common example of system software. Device drivers, which help hardware components communicate, are another. Utilities that help manage and maintain the computer also fall here. It works in the background, making sure everything runs smoothly. You don't always see it, but it's absolutely essential. It's the unsung hero of your device's functionality. Application software, on the other hand, is what you usually interact with directly. These are the programs you use to get things done or have fun. Word processors, spreadsheets, video games, music players, social media apps, all of these are application software. They are designed to perform user-specific tasks. Computer engineers, especially those leaning towards software engineering, play a huge role here. They ensure software is efficient, reliable, and works seamlessly with the hardware. It's about creating great user experiences through code. This synergy between hardware and software is crucial. So, how does software actually get made? That's where programming comes in. Programming is the process of writing instructions for a computer to follow. These instructions are written in special languages called programming languages. Think of it like writing a very detailed recipe. The computer then reads this recipe and performs the steps exactly. This is how developers create software, websites, and apps. It's a fundamental skill in the world of computer engineering. It's the bridge between human ideas and computer actions. Programming is essentially telling a computer what to do step by step. Imagine you want a computer to add two numbers. You can't just tell it add these numbers in plain English. You need to use a programming language. This language has specific syntax and rules like any human language. The programmer writes code, which is a set of these instructions. The computer then processes this code to achieve the desired outcome. It's a logical and precise process. A tiny error in the code can lead to unexpected results. So, attention to detail is super important for programmers. There are many different programming languages out there. You might have heard of some like Python, Java, C++, or JavaScript. Each language has its own strengths and is often used for specific types of tasks. Python is known for being relatively easy to learn and is popular for AI and data science. C++ is often used for game development and high-performance applications. Java is widely used for enterprise applications and Android app development. JavaScript is the backbone of most interactive websites. Computer engineers often need to be proficient in one or more of these. Choosing the right language for the job is a key skill. Programming is a core skill for computer engineers. It's absolutely essential. It allows them to design and control computer systems at a deep level. Whether they are working on hardware design, firmware development, or software applications, understanding code helps them bridge the gap between the physical and digital. They might write code to test new hardware components, or develop firmware that makes hardware function correctly, or even build complex software systems that run on the hardware they designed. It's this ability to speak the computer's language that makes them so effective. Programming empowers engineers to bring their designs to life. Section 5. Why computer engineers matter so much. Now let's talk about why computer engineers are so incredibly important. Think about it. They are the architects of our digital world. Almost every piece of technology you interact with has been touched by a computer engineer. From the smartphone in your pocket to the complex systems running global communication, they design the hardware that powers everything. They also help ensure the software runs smoothly on that hardware. Their work is foundational to the tech industry. Without them, innovation would slow to a crawl. They are truly indispensable in today's society. Computer engineers are at the forefront of driving innovation. They are constantly pushing the boundaries of what's possible. They develop faster processors, more efficient systems, and smarter devices. This innovation isn't just limited to the tech sector. It impacts healthcare, transportation, entertainment, education, and so much more. Think about advancements in medical imaging or self-driving cars. Computer engineers are key players in these breakthroughs. They are the ones turning science fiction ideas into reality. Their creativity and problem-solving skills are vital for progress. The work of computer engineers directly improves our lives. They create technologies that enhance efficiency and productivity. Businesses can operate more smoothly thanks to the systems they design. They build the infrastructure for global connectivity. This allows us to communicate and share information instantly across the globe. They also contribute to a better quality of life in countless ways. From entertainment systems to smart home devices that add convenience, their contributions often work silently in the background, but the impact is undeniable and profoundly positive. Simply put, much of the modern technology we take for granted wouldn't exist without computer engineers. The intricate dance between hardware and software requires their expertise. They ensure that these two sides work together harmoniously. They troubleshoot complex problems and find solutions. They optimize systems for performance and reliability. So the next time you use your favorite app or gadget, take a moment to appreciate the computer engineers behind it. They are the unsung heroes building the digital future. Their role is more critical now than ever before. Section 6. Computer engineering in your daily life. You might be surprised by how much computer engineering impacts your daily routine. It's not just about high-tech labs or giant data centers. It's in the everyday objects you use all the time. Take your smartphone, for example. That's a marvel of computer engineering. From the design of its processor and memory chips to the way its operating system manages all the apps, computer engineers were involved every step of the way. It's a mini computer in your pocket thanks to them. This device alone showcases their incredible skill. Think about your entertainment. Love gaming? Gaming consoles like PlayStation or Xbox are packed with advanced computer engineering. The powerful graphics cards that render stunning visuals, the custom processors that handle complex game physics, the network interfaces that allow for online multiplayer experiences, all of these are the result of dedicated computer engineers. Even streaming services that deliver movies and music to your devices rely on vast server infrastructures designed and maintained by these pros. Your leisure time is heavily powered by their work. What about getting around? Modern cars are increasingly technological. Many new vehicles have sophisticated computer systems. These control everything from the engine management to the infotainment system. Features like adaptive cruise control, parking assist, and navigation are all made possible by embedded computer systems. Computer engineers design these systems to be reliable and safe. They are also at the forefront of developing self-driving car technology. This is a huge area where their expertise is transforming an industry. The car in your driveway is smarter than you think, and it doesn't stop there. Consider healthcare. Medical devices like MRI scanners, pacemakers, and robotic surgical tools all rely heavily on computer engineering. They help doctors diagnose illnesses more accurately. They enable less invasive surgical procedures. They monitor patients' vital signs in real time. The precision and reliability required in medical tech are immense. Computer engineers rise to this challenge every day. Their work saves lives and improves health outcomes significantly. Section 7. Getting started, education and essential skills. So, you're interested in becoming a computer engineer? That's awesome. Let's talk about how you can get started on this path. Typically, the journey begins with education. Most computer engineers hold a bachelor's degree. This is usually in computer engineering, electrical engineering, or sometimes computer science. These programs provide a strong foundation in the core principles. You'll learn about electronics, circuit design, software development, and much more. It's a challenging but rewarding academic journey. This formal education is often the first big step. What kind of subjects will you dive into? Mathematics is a big one. Calculus, linear algebra, and discrete math are crucial. Physics is also important, especially for understanding electronics. Of course, you'll take many computer science courses. These cover programming, data structures, algorithms, and operating systems. You'll also study digital logic design and computer architecture. These subjects teach you how computers are built from the ground up. It's a comprehensive curriculum designed to build expert problem solvers. Be prepared to hit the books and engage in hands-on lab work. Beyond the degree, certain skills are super important for success. Problem solving is at the top of the list. You need to love tackling complex challenges. Analytical thinking is also key. Being able to break down problems and examine data. Creativity might surprise you, but it's vital for designing innovative solutions. Don't forget attention to detail. Small errors can have big consequences in engineering. Good communication skills are also valuable for working in teams, and a strong desire to learn continuously is a must. This field changes so rapidly, you always have to be learning. The tech world evolves at an incredible pace. What's cutting edge today might be standard tomorrow. So, a commitment to lifelong learning is absolutely essential. This means staying updated on new technologies, programming languages, and tools. Reading industry publications, attending conferences, and taking online courses can help. Many engineers also pursue further certifications or even master's degrees. This continuous development keeps your skills sharp and relevant. It ensures you can contribute to the next generation of tech. Embrace the journey of constant learning. It's part of the excitement. Section 8. Your career path, opportunities, and growth. Once you have the education and skills, what kind of career can you expect? The great news is that computer engineering offers a wide range of job roles. You could become a hardware engineer, designing physical components, things like processors, memory chips, or circuit boards, or perhaps a firmware engineer writing low-level software that controls hardware. Systems architects design complex computer systems and networks. There are also roles in testing, quality assurance, and research. The options are diverse, allowing you to find a niche that fits your interests. You can really tailor your career to what you enjoy most. Computer engineers are in demand across many different industries. The tech industry is an obvious one, with companies big and small hiring. Think Google, Apple, Intel, Nvidia, and countless startups. But the opportunities extend far beyond just tech companies. The automotive industry needs computer engineers for smart cars. Healthcare relies on them for medical devices and systems. Aerospace and defense, finance, telecommunications, and even entertainment. Pretty much every sector needs computer engineering talent. This broad demand means good job security and many choices. What about career growth? The potential is significant. You might start in a junior engineering role, learning the ropes. As you gain experience, you can move into senior engineering positions. These roles often come with more responsibility and complex projects. Some engineers choose to specialize in a particular area, like cybersecurity, artificial intelligence, or embedded systems. Others move into management, leading teams of engineers. Or you could even start your own tech company. The path you take depends on your ambitions and skills. The demand for skilled computer engineers is consistently high, and it's projected to keep growing in the coming years. As technology becomes more integrated into every aspect of our lives, the need for people who can design, build, and maintain these systems will only increase. This means strong job prospects and competitive salaries. It's a field where your contributions are valued and rewarded. If you're looking for a career with long-term stability and exciting challenges, computer engineering is definitely worth considering. The future looks bright for those in this profession. Section 9. The future is yours. A message to aspiring engineers. So, you're thinking about diving into computer engineering. That's fantastic. It's a field that's challenging, no doubt about it. There will be tough problems to solve and complex concepts to learn, but it's also incredibly rewarding, deeply satisfying. You get the chance to be at the forefront of innovation. You get to build the technology that will shape the future. Imagine creating something that millions or even billions of people use. That's the kind of impact you can have as a computer engineer. It's a powerful and exciting prospect. The core of computer engineering is about solving real-world problems. It's about using your skills and creativity to make a difference. Whether you're developing more sustainable tech or creating tools that improve healthcare or education, or even just building really cool gadgets that people love, your work can have a tangible, positive impact on the world. This sense of purpose is one of the best parts of the job. You're not just coding or designing circuits, you're building a better tomorrow. That's a pretty amazing way to spend your career. My advice to all aspiring computer engineers out there, stay curious. Never stop asking, how does this work? Or how can we make this better? Embrace the challenges. They are opportunities to learn and grow. Don't be afraid to experiment, to try new things, even if you fail sometimes. Failure is just a part of the innovation process. It's how we learn. Keep learning, always. The tech landscape is constantly shifting. The skills you build today will be the foundation for tomorrow's breakthroughs. Your passion and dedication are what will drive you forward. The world needs bright, passionate computer engineers like you. We need your ideas, your skills, and your unique perspectives. You have the potential to create the next wave of technology, the next big thing that changes how we live, work, and play. So go for it. Dive in. Work hard. The future of technology is in your hands. And trust me, it's going to be an amazing ride. Build that future. I can't wait to see what you create. The possibilities are truly limitless.